And welcome back to the stream, everyone. Um, Today's stream will probably just be a little shorter than usual. So um, I'll probably be finishing today's one up after about an hour. So I'll basically just be focusing on continuing this mini project of converting the get Docker script into this kind of new Laurel programming language that I'm developing. Last week, I added some extra functionality for working with strings. So um, that might be something that we get to use today. But yeah, I suppose I'm just going to dive right in. Um, the next bit of this script is what I was working on last time with our guest. This script is setting up commands to exit on failures by default, so kind of panic on command failures, and you have to catch that in order to recover. The last statement that we converted was this, so just retrieves the user ID. Uh, I'm actually running, excuse me, this project inside a Docker container, so as we can see, the user that I retrieved back here, even though if I run the command in here, we do get the user kind of name, I guess, or user ID as 1000. But if we take a look at the exit code from that, we can see that even though we get an output, the command actually fails. So in that circumstance, and similarly to this program, I guess, in that situation, the well, actually, here's a point: is that in this case, the output from this would actually still be the standard out of the command. So even if the command fails, we take the standard output of the command. The way, just reading this now, the way I had it was that I overwrote the value. So what I'll do here is, yeah, this kind of highlights a good point that in the case of an error, there ideally needs to be some kind of functionality to retrieve, um, I suppose. So the default behavior will be to kind of crash the program as such, but this error condition should also contain, I guess, for example, in the case of commands failing, we still want to capture everything related to the command so that if we do decide, first of all, we ideally want to be able to check what error code, if any, was present, and um, allow ourselves to continue on in the case of a recoverable error. So in this case, so that kind of indicates a little bit of reworking in the current approach. So if I take a look at where the evaluation is currently being handled, this would be a command that's being run. And yes, we can jump to subcommand maybe. And where is the error exit behavior? I haven't kept the name. No. So in that case, let's see. I'm probably looking for command still. Yeah, create a new program or create a new command there. Um, and we have an exit code. And in this case, what we're doing is, in the case of an error condition, we actually, yeah, return an error. However, what we probably want to do is change our error handling so that instead of returning an error string, we return an error object that contains, for example, a message. So kind of a human readable message so that a human operator knows what happened. Maybe an error code so that if we do want to handle this properly, we have an opportunity to do so. and potentially any extra information based on the code. So if the code was process exited with a value of 0, then in that case we'd want to pass the actual process result with the error. Having said all that though, that would probably be a hefty amount of work to do today, especially since it would require refactoring a lot of the existing error messages. So what I might do is add that as a to do, and it's also something to kind of research as well, like exactly how I'm going to approach this. Because while I say that is a possible approach, I still need to take another look into, is that definitely how I want to work this. So error handling, keeping the error, or for example, keeping the result object, because that, I suppose that's what makes sense to me for now. But having said that, it could be, that's half on the basis of wanting to have this default behavior where if having error exit behavior as default, and what that means is then if the error exit behavior is default, then we need to incorporate um, kind of capture of those variables into the error handling mechanism, so that even if an error does happen by default or and trigger the default error handling mechanism, that we're still able to get the information that we need from the source. You know, I could structure this in another way where error exit isn't the default, in which case in which case I don't need to have this extra kind of error source object. But I suppose there are different considerations that need to go into that. So that's something I'll put in as a to do there as well. So I'll just make a note that this line isn't actually converted properly, and it should take the standard out of the ID process as a result. So yeah, that's an interesting thing that I overlooked the last time. So yeah, I'll definitely need to resolve that at some point. So then the next part is it does a bit of the script does a bit of logic here to essentially set up a mechanism for use in the rest of the script, so that all commands that get run can be, or in order to run commands as the super user essentially. So it does a couple of things here. It says by default, the so it checks is the user root. If the current user is root, then we can just use shc, because commands will then be run as root. But if we're not, then we need to set um, up shc so that it is run using sudo. If sudo isn't available, then we try it with su. And if neither of those are if none of those options are available, then we quit. And finally, if um, if we decide that this is a dry run, then we just output the commands to standard output instead, which could be useful for debugging. One thing to know is right off the bat here as well is that you can't do a dry run unless you're an admin anyway, or unless you have admin privileges. So you can't see what this script would run um, as a kind of a regular user if you wouldn't have permission to run the script anyway, or wouldn't have the features necessary to run the script. So that's an interesting piece to note. So what I'll do is I'll just squish this up to the side a little here, although I've kind of lost my place now. So I'll squish that up like that. I'll move that over here, and we'll continue on from here. So first thing to do now, whether I'm going to keep this logic as is, again, this was, so we can see that there's a lot of stuff going on kind of inline in this function, I guess. And one of the reasons for that could be just that, well, I'm not quite sure why they didn't split some of these out into separate functions. But what I might do here is I might do that. So for example, I could have a new function here called, you know, maybe def, um, oops, get shc um, sub command, I guess. We'll call it that for the time being. And then in here, what we can do is I'll probably refactor this to be a little kind of more Go style. It is an idiom that I do kind of like, having having guards and returning early based on certain conditions. So for example, in this case, I might see, so first of all, we will need the user that we got from earlier. So this will be get shc subcommand based on user. If user is equal to root, then we can return this. And one nice thing about this as well is that the way that, it's not problematic as such. It looks kind of neat, but the way Bash would run this or utilize this variable in future, then we can probably see it in future bits. Let's see where references to shc. Yeah, exactly. So essentially what it'll do is it'll do a kind of dollar command expansion and pass the command to run using that subcommand, pass that as a string. And things like that, again, they're functional. I find them a little tricky because you do, I feel, with things like dollar expansion and string handling and interpolation, I do feel that those things are a little tricky. In this case, I think it's kind of nice that when I'm when this language will be constructing the same thing. For example, I'll be constructing shc here as the subcommand, and this kind of makes it, when this is returned, this is constructing an explicit subcommand. This isn't a string anymore, or a sequence, or a list of strings. This is actually kind of a pre-prepared subcommand that, if it's given arguments, it'll take those arguments as extra positional arguments and run the command. At this point in time, you don't necessarily know that, you know, you could have an inkling, a very strong hunch that that's how this is going to be used as well. But at this point in time, this is kind of a dead string literal. Again, I'm not necessarily saying that one is necessarily better than the other, but I do like this idea that we're adding more kind of almost typing information here, so that we're better positioned to use it in the correct way, hopefully. So the next piece to do then is, yeah, if command exists sudo. Um, and we have our command exists function. So we can just pass in sudo here. And if that does exist, then we return similar to the bit above, but in this case, we have sudo and it takes an e parameter or an e flag. Yeah, I think that should do it. And similar with su, it'll be so I think su and c without any other, or yeah, su without any other parameters will run it as the root. And then if we get to the end, then I think we have a panic function at the moment. So I'll just put in a to-do piece here, but essentially what it'll say is it'll give this information. So something like error this installer dot 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 to do. So that should be enough to at least get the shc command and somewhat authorizes the use of the script. So I'll store that there. I can check for a dry run as well at this point. So I store that in args at the moment and in parse args. So I'll pass that to the install script now that I'm referencing it. And I'll say if args, what do I say? Dry run is equal to true. So if args dry run, should I decompose that here so that, in fact, yeah, let's try it like that for the moment because I don't know that I need all of those arguments just yet. And I'll call this is dry run as well, just to make the Boolean operation or the Booleanness of it more explicit. So if it's a dry run, then sh will instead be, so that'll have to be put in, declared using let. Now this is something I might refactor as well. I originally had this as this kind of a setup. As I see all the lets throughout here, I think it might be more appropriate for a scripting language to keep it lightweight, but that's just something I've been thinking about recently. So in this case, the sub command here is just echo. Now, this will be kind of a strange one because at this point in time, even though I was talking about how these are explicit subcommands these by the time they're defined, this is actually still a string literal. It's kind of hopefully made more clear that it's intended to be used as a subcommand owing to the fact that it's being declared without quotes. But at the same time, at this point, it's still just a string literal. It doesn't have any extra information to say that it's a subcommand and that it can only be used as a subcommand. But at least later on, the extra the way it's used should hopefully then clarify that it's a subcommand. And what I might do as well at some point is introduce extra syntax so that in these kind of cases that it can be made explicit that it's to be used as a command. So yeah, that's that section done then. Perform some rudimentary platform detection. So in this case, we have let lsb dist is equal to, so get distribution, is that a function that we're calling here? Yeah, so I'll just grab that, and I prefer to define uh, functions and things after they're actually used. So I'll put get distribution down there. I don't need to call it as a subcommand because in this language, this is just a regular function call. This does some additional processing on the result actually. So I wonder, is get distribution used in other places? It isn't, so I'm not quite sure why this kind of post-processing wasn't performed in the function itself. I don't want to refactor it too much and potentially change the spirit of the program, but I think that could be all right in this case. So I'll change this so that it's the value is returned there. And essentially what we're doing is converting everything to lowercase. So what I can do in that case is return dist and something like to lower. So what I'd like to do there is just get the equivalent function for Rust and use that to implement the standard library implementation of this for now. So it does it based on Unicode derived core property lowercase. So it's not just kind of ASCII conversion. Although actually that's an interesting point because strings in this language are defined essentially as ASCII. Well, they're essentially byte strings. So in that case, I've probably two options here. I could convert it to a UTF string, convert it to lowercase, and then convert it back. What I'll probably do is, yeah, that's an interesting point, because technically in this state, the behavior of this probably does isn't the clearest. But what I'll probably have in future is an extra kind of standard library, hopefully to handle UTF-8 matters. So there'd probably be something like UTF-8 to lower, and it would take a string, maybe something like that. Right here, though, I'll probably just do the ASCII based approach. So I'll look at prototypes, and let's see, strings. So I've got strip prefix and I've got starts with. So I'll update that to also define to lower. And what does Rust call it? I'll probably be following Rust's and naming for a lot of these because I do like how Rust does things in general. To lower case. So, oh no, so this one, this won't take an argument again. That's something that I'll have to um, um, prevent at some point. And in this case, it'll actually mutate the thing that's being referenced. That's an interesting point. Will it mutate it, or will it create a clone that that then gets mutated? Maybe I'll do the latter for the moment anyway, and again add another to-do comment to consider the different approaches. So get a string here. What I'll probably do is, yeah, just go through each and do an ASCII conversion. Any uppercase characters will be converted to lowercase. So let's see, what's my best way of iterating through those characters? Can I do a map, I wonder? Yeah, because this is actually just a vector of U8s, so iterating should be fine. What I'll essentially be getting out at the end is a new string. And the value will be, I'll just call it X for the time being. And X will be defined as S, we'll say iter. Apologies. I felt that one coming for a while. So so we go, yeah, iter map maybe, and we'll see. So if this could be something like call it a character even though it's an integer, and I'm not sure if yeah, I don't think Rust has the ternary operator. I think we actually have to do an if else. I'm not sure if this is really the kind of syntax that I want to go with, but anyway, what I'll say is if C is less than, basically outside of the range of uppercase characters, so uppercase starts at 65, or if it's greater than, let's see, and 90 in decimal. Can I do integer comparisons on runes, like on characters in Rust? I assume not, but I'll take a look anyway. So let's see, um, X is less than 65, for example. I'll try running that. Yeah, expected a character. So those kind of comparisons can't be done in a kind of traditional C-like way, which is probably for the best. But in this case, let's see, if it is an uppercase letter, then I want to add the difference between the uppercase letters and the lowercase letters. I'll have to do a bit of a test on this in a minute, but let's see. So the difference between the two is 32, I believe. Oops, how did that happen? And that is probably fine. I just have to let in a guest. One moment, please. So yeah, that should be about enough to run. Let's take a look. So what's happening here? Um, yeah, need a semicolon. Expected address of a C because of that. Can I do that to make it explicit that? No, I certainly can't. Maybe I'll do those like that. Oh, I accidentally converted that to uppercase. 117. And I somehow got a map structure. Oh, yeah, of course. So I need to collect it then at the end. And 103, yeah, not using that. Maybe I'll change that to just be called to lower. Oops. Okay, so that's compiling at least. So let's take a look. Actually, I didn't print the outcome of SHC. And I also want to print the result of LSB dist. And even before I get into those, I'll do a return null, and I'll just test the functionality of this on its own. So yeah, so that the handling of string casing, the function for that seems to work at least. Um, Here we just have the string echo. That's because we've handled, we've allowed for dry run. I'm actually not sure why it's allowing. I just realized. Feel like this should actually panic. Um, Unless we're running as root. I'm not sure. So, oh, that's not how comments work. I'll just remove that line for the moment. So in this case, okay, so I am actually, oh no, it's that Sue exists. So okay, interesting. So I don't have sudo, but I do have Sue. Cool. But then that gets overridden because I'm saying it's a dry run, and the distribution I'm currently running in is an empty string. So let me just confirm that as well in the same container. So if I run, um, let's see, etc. OS release, and I uh, test R is readable. That doesn't actually work, I don't think, and that's probably something I needed to correct. That was probably written before I had the actual error exit functionality. So what I'll do in that case is I'll grab that, let, I'll just call it X for the moment. That should be captured because we want to continue regardless. And I'll print the output of that command there. And what should it do at that point then? It'll source the file. Oh yeah, because and it should then output the ID variable from it. So in this case, yeah, exit code is 0. So all we really want to do here is find out um, whether or not the file is readable. I could probably put that into its own function. Actually, it would probably make things a little clearer. But what I can do is that for the time being anyway. And let's try that now. Cannot bind to a string literal. What's going on there now? So I'll go print hi, just to make sure that I'm seeing the right thing. Oh, I have ampersands there. Yeah, that's not, although, sorry, that's ampersand because it's being passed to SHC. Maybe I'll put that into a new variable for, oh, that's because that's not a string, or not a variable, that's a string at the moment. So yeah, so that's actually Debian. So I'll get rid of that. I'll also want to trim the right of that. So let's see. Rust vec. Is there something like trimming in vectors? I don't see it. I might have to define it myself as well. Yeah, I'd find that in string, but not in vectors. So let's go back to the string prototypes and trim right, and it'll essentially remove any characters that that are white space. see. So maybe I can do a filter in this case and basically see, well, just double check and Rust iter filter. I'm guessing that's the thing. Yeah, I believe so. And if I get my ASCII table back, actually. So the white space characters that I'll be interested in are mainly space, new line, form feed, carriage return, um, vertical tab. So this. So that range from 10 to 13, and the space character, so character with decimal number 32. Though a lot of these could probably stand to be removed as well, but I'll just keep it simple for the moment. So in this case, I'll say it's not if the character isn't character 32, and I probably have to dereference that as well. But if the character is less than 10, or the character is greater than 13, and the character isn't 32, then it can be kept. So let's try that. Yeah, I probably need to dereference those. Will that fix all my problems? No, I'll actually have to expand that to see what's going on. Expected address of an unsigned integer, but found an integer. Did I need to do those dereferences? I'll just double check. So those seem to be doubly referenced for some reason. That's an interesting one. So why is that happening? Let's just take a look at filter. Well, first we need to jump to find the definition of iter. It's probably one of these trait definitions. Nope. Okay, filter. Hmm. Okay, yes. So because closure past filter takes a the closure past filter takes a reference. So this is Yes, a reference to the item as opposed to, okay, so if I jump to map, um, okay, interesting. Map takes the item itself because it might need to modify it. Um, Whereas for filtering, we know that it's always going to be read only because the value returned from the um, filter is a Boolean, whereas for the map, it could be the item itself. I'm not sure, but yeah, at least in this case, it makes sense. I think because it's a you know it shouldn't need to mutate, and it shouldn't need to, and it shouldn't mutate the originating value. So because it takes a reference and many iterators iterate over references, this leads to potentially double references. So it's common to instead use destructuring on the argument to strip away one. Ah, interesting. And maybe I can do that with my, that's probably what I should have done up there. So if I do that, yeah, my errors are still within this, the confines of this function. And I wonder, can I strip away two of those because I don't really need it, I don't think. Yeah, or both of these layers. Um, cool. And then 141, uh, value of type vec u8 can't be built from an iterator. So 141, so it's using type inference, I guess, to know that trimmed S needs to be. Okay, so is it actually No, it shouldn't be modifying the original. Why am I getting an iterator of references? Is it because of this? So if I removed that and put it here, that doesn't make total sense to me. No, yeah, that wouldn't make sense, I don't think. Um, so the result in this case, it's building up a list of references. Whereas if I do a map, they're not. Because it's returning um, references to the original. Um, the original list, is it? Yeah, it must be. So it's filter in this case is actually creating more of a view as such into the original iterator, or into the source of the iteration. I'm not sure if this is the way to go about it, but could I then map that to remove the reference? That doesn't feel right to me, but maybe I suppose if it works for the moment anyway, that's all right with me. Though it doesn't work in terms of actual runtime. So let's take a look. Um, so if I go print hi, so I'm actually removing all white space from the string rather than white space from the ends. Um, so what's my best way of doing that? I'm probably better off actually If I do a for in something like slen -1 all the way down to 0, basically get the last non-white space element from the string. What's my best way of doing that? A pretty pretty silly implementation potentially, but if it works, so if it's, so this is kind of the opposite condition. So if it's outside of those ranges, then it's fine. What I want to do is so I'll just throw that in a big knot at the moment, and then I can use De Morgan's theorem or something to kind of flatten it out in a bit. So let's try, and then what I want to do next is, though there's a potential for an off by 1 error here that I'll need to be careful of. But what I'd like to do is, let's see, from the last non-white space, so collect everything. So is that something that's possible? Expected expression 149 expected a vec, but got that, so we can maybe convert that to a vector. That needs to be made mutable. And we'll try this now. So it didn't print high. Oh, because I haven't actually run this, or I haven't actually saved that since the last time I modified it. So let's go trim right. And that worked. Oh, and that actually fixed the Debian version as well. So yeah, that seems to be working away grand now. I thought there would be an off by 1 error here potentially. I do want to check how it works on empty strings. So if I did empty string trim right, what would happen here? So first of all, last non-white space would be 0, so that should actually be fine in that case. But what if it just had a single, oh no, attempted to subtract with overflow, so that's attempting to subtract when it's a U size. So what happened here? Oh, when attempting to do that actually. So yeah, so let's see. I'll work through this, and if I give it a string with just a single space as well, I'm guessing that will. Oh, that's actually all right. So it's actually just an edge case, which realistically I'd like to handle in a different way, or sorry, not in a different way, but in the same way as the rest of the algorithm. But for the moment, I could do something like this. And if I had slen is equal to 0, do that. And while I do like to handle edge cases as part of the main loop, I think that actually kind of makes sense in this case because the algorithm works off the basis of checking the last element of the string. But if there is none, then we can't even get into this loop. So that's probably all right. And let's see. So just to recap on this, so sets it to the last character. If we're still looking at characters, then we check what character we're on. If it is white space, or sorry, if it isn't white space, then we jump out, and this will be already. This will then, by nature of that, be set to the index of the last white space character. Otherwise, we go on to the next one. I have to admit, a little tired today, so that makes sense in my head. I'll have to, to verify it at a later time. But at least the functionality seems to work. So we get Debian back, and that seems to be working okay. So so yeah, our LSB distribution in that case is Debian. So yeah, let me go ahead and actually there's been a couple of things happen there. So it's not quite an atomic commit. This is kind of playing around. Some white space errors there. And commented out code, so double whammy of bad practices, but let's see. And oops, 171. Yep, there we go. And the message here is, in fact, do I have other messages for this project? Convert X of Docker script. So in this case, so in this case, the thing that I converted was what? just part of the setup. Cool. And yeah, it's kind of coming up to the hour. I decided to do kind of a relatively short stream today, but I'll take one look at the next little bit of the processing and see what it involves. So we did this conversion. The next little bit is just to check if it's WSL and abort if it is. So that should be straightforward enough to convert. So in this case, we do if is WSL, and does that take any parameters? No, it does its own thing. So it does uname command. Does it does it catch any failure? So yeah, so if that did fail, it would actually, so if uname wasn't available, it would actually abort the script. So in this case, that's all right. And if it is WSL, then we do a panic, and that'll be WSL detected. We recommend such and such. And it does some extra processing there, but I won't handle that. Cool, and that was just a small little whoops, and I pushed it. So what's the invalid token? That was very silly of me. So is WSL. So it's something that I introduced just there. Um, oh yeah, so strings do not use that syntax. And property name contains. So that's so that's just plain not implemented. So that so I'll need to correct that at some point. For now though, I'm actually going to leave it there. Yeah, just some small progress made on the ongoing Docker script conversion, but you know it's getting there. Let's see what percentage through. So a little over halfway is. I think there's still some bits higher up that I haven't that I've kind of deferred implementation of. So might not be exactly there, but yeah, it's going somewhat steady. So yeah, thanks to everyone who checked out the stream, and take care. Talk to you later.